Hello and welcome back to this amazing channel. This is Abhinav. So in this particular video, we'll discuss about the problems of contest Codeforces Round 936. This was actually a tough contest. I have not attended the contest during the time because I was little busy today with my office work, right? But the contest was really tough. As I can see, the number of submissions for the fourth problem was very low during the contest. After it was increased. During contest, it was just around 200 submissions. So it was a good contest. Even all the three problems A, B, C are of good level. Okay. So I absolved. So like in these last 1 hour after the contest, I tried solving this problem and I absolved the first three problem. For the fourth problem, I tried, but it was taking more time for me. So I thought to first upload the solution for the first three, and then we will discuss the other problems, right? So in this particular video, we will discuss the first three problems A, B, and C of this particular round, okay, which is 936. Okay, cool. So let's discuss the very first problem, which is median of an array. This is a problem where basically you are given with an array. For example, the array is 95129. Okay, and first of all, you have to find the current median of the array. What's the current median of the array? So basically, the current median of the array is the middle element of the array. For example, after sorting it, right? After sorting it. For example, if you will see this array, if you will sort it, it will become 1, 2, 5, 6, 9. Okay. So this 5, this is the median, right? In case of even length, for example, the array is this. If you will sort it, let me make a change. If you will sort it, it will become 1, 2, 3, 4, 6, 6. There are two middle elements. So basically, this element is considered as medium according to our definition, right? So that's the basic thing that we have to do. So if you will actually find how we are basically, you know, calculating the middle element. So if we have zero base indexing, if we have zero base indexing, and if we have n elements, for example, in an array, so n minus 1 by 2th element means the element present at n minus 1 by 2th index will be your median element. For example, here n is 5, so the median is at 2. Here n is 6, so median is at again 2, right? So that's the first observation, that median element is present at n minus 1 by 2th. Now what you can do is you can increase each element of this array by 1 any number of time, but you have to find minimum number of time you can increase such that the whole median of the array got increased. For example, if you have to increase the median of this array, right, what you will do, you can simply increase the value of this 5. You will make it 6, and when you will make it 6, the whole median will become the median of the whole array will become 6. But that is not true in every case. If you will see, if let's say the array is like this, in this case, if you will even increase the value from 5 to 6, after sorting it will again remain 5. Means you have to increase the value of all the 5s, not just this 5, of all the 5. This also will make to 6. So here two operations are required, right? Similarly, if let's say it's something like this, for example, here this is the median. If you have to increase the median, you have to obviously increase the value of this 5 to 6, but not just this 5. You have to increase the value of all the 5s to 6. Why? Because after sorting, no matter the later y will come first, so median will remain 5. If you have to increase the median, you have to increase all the values of 5. That's the thing. Similar in case of even also. This is the median. Here 3 is present only once. You will simply increase the value to 4 and median will increase. For example, if the thing is like this, let's say. In this case, if you have to increase the median, so by just increasing this 3, it will not work. Why? Because if you increase it, after sorting, it will again remain 3. So you have to increase value of all the 3s. That's the basic thing. You have to find the middle median element, and now all the elements which are equal to that median, you have to increase their value by 1, and that is the number of operations that are required, right? So if you will see like how I solved this particular problem. So yeah, how I solved it, I first taken the n and the count, then I have taken the input of the vector, right? Now I have sorted the vector. Obviously we are sorting it to find the current median, And as we discussed, current median is present at index number n minus 1 by 2. Now again what I told you, all the numbers which are equal to that median value, if you have to increase the median, you have to increase all those numbers. So for all the numbers from that index number x to last, which are equal to the index number x, which is the median, we have to increase it. That is why we're increasing the count. And finally, our count is the answer. Right. So this is how, guys, we are solving this first problem. This was actually a very interesting problem, and you must have learned something new in this particular problem, right? So let's move to the next problem. Before moving on, let me tell you one thing, that I have prepared a CP sheet, okay, of basically 150 questions, right? And one more thing, that most of these questions will contain video editorials by me. Yes, so most of these questions contains video editorials by me. I have prepared a sheet of 150 questions that will help you from newbie to specialist. So the difficulty of this sheet is from newbie to specialist. It contains 150 code forces and code safe questions, and all the questions have their solutions recorded by me. The sheet is completely free. If you want that sheet, you can just DM me on Instagram. So my LinkedIn is already full a lot of with different messages. So I will refer you to, like, I will recommend you to message me on Instagram. Just send that, hi Abhinav, I saw your video, and please send me that CP sheet, and I will share the link of that CP sheet there. Why I am not sharing it here? Because I just want serious people to get that. I don't want it to marketize that CP sheet. It's Abhinav CP sheet. No, it's simple. It's a CP sheet of 150 questions where editorials are recorded by me, and the complete sheet is completely free. So do DM me on Instagram. You will get the ID in the description, and I will send you the CP sheet, right? Amazing. Now let's move forward to the next problem. So the next problem is problem number B, which is maximum sum, right? So this problem is basically, this was again a very interesting problem where there's a very good use of modulo arithmetic is done. The problem says that you are having an array n. Okay, so we are having an array, right? Let's take an array. For example, the array is something like this. Okay, so this is the array given to us. Now, what we have to do with this array? So we can first of all choose a sub array of this array. What we can do? We can choose a sub array of this array. We can find the sum of that sub array. So you can choose any contiguous sub array. So we will choose a contiguous sub array from this array. Now we will find the sum of that sub array that we have chosen, and we will insert that sum in the same sub array anywhere in the same sub, right? And we can repeat this operation how many times? K number of times we can repeat this operation. Okay, and by doing this, we have to find the maximum possible sum of the array after k such operations. And after k operations, what will be the maximum possible sum, right? And that we have to find with the modulo 10 to the power 9 plus 7, because that value can be very large, right? So let me tell you how we can do it. First of all, guys, we have to take a sub array. Okay, and now after finding sub array, we will find the sum of the sub array, and then we will insert the sum of the sub array as the element in the same array, right? And by doing that, we have to increase the overall sum of the array. So if we have to increase the sum of the sub array after doing k operations, what we will do? We will try to get a sub array which is having a maximum sum. And guys, how we can find a maximum sum sub array? Can you guys tell me? Yes, there's a very famous algorithm called Cardan's algorithm. So if you guys don't know about Cardan's algorithm, please learn it. Basically, this algorithm is used to get the sum of a maximum sum subarray. For example, if you will see in this particular array, this subarray has the maximum. You can see none other subarray will have sum more than this. If you will take this, any other, it will not have, right? So this subarray has the maximum sum, which is basically what? So it is basically 10, I guess. Yeah, the overall sum is 10. Even that can also be the case when all the elements are negative in an array. In that case, there will be no such subarray. A empty subarray can be taken, and that is also possible. It's saying possibly empty, because if all the elements are negative, we will not take any. It will reduce our sum, right? So, but in our case, what we will do, we will take this as our subarray. Okay, we will take this as our subarray. So let's keep other elements aside. What I will do now, I will keep this 4, -6, -7 and 3 aside. Now whatever we will do, I will do with this particular subarray. Let me tell you why. First of all, we have to do k operations, right? We have to do k operations. These elements are remaining. Okay, let's keep it aside. Let's discuss about this subarray. For example, let's say this is the subarray currently present with the sum 10. What I will do, in the first operation, what will happen, I will take this subarray, I will find its sum, which is 10 actually, which is 10, and I will again insert the 10 in the same array just after this subarray. So means currently subarray was what? So after first operation, subarray was this, and now its sum is also added here. Its sum is also added. Now subarray, now we will take this subarray. So in the second operation of k, we will take this as our subarray. Now, when we will take this as our subarray, what will happen? The overall sum will be 20. Now we will add 20 here. Now sum became 40. In next operation, it will become 40 plus 40, 80. In next operation, it will become 80 plus 80, 160. Then in next operation, it will become 160 plus 160, 320. So this is how the sum of that subarray will get on double, because we are getting the sum and we are again inserting the same sum. So sum of that subarray that we are choosing will keep on increasing, will keep on doubling basically. It will get doubled by 2 every time, right? And after k operations, what will happen? The sum will become 2 to the power k times. So whatever the sum of that subarray was, it will become 2 to the power k times. So when k is 1, it will become 2 times. When k is 2, it will become 4 times, then 8 times, then 16 times, then 32 times. You can see here. Initially sum was 10. It became 20, then 40, then 80, 160, 320, 640, and so on. Right? This is how the sum will increase. Okay. So basic agenda is, first of all, we will find the subarray with the maximum sum. Let's say so in my code I have taken it as an answer. So my answer will come as 10. What is this answer? This is the maximum sum of a subarray that we can get. Right. Now this 10 is the sum of the subarray that we are considering. For remaining digits, the remaining digit na, this will also be considered. We cannot ignore them. So remaining digit we will store in a separate integer. Iska sum. So iska sum will be -6, -13, 10, it will be 14. No, sorry. It will be 6, I guess. 7, 3, it will be -6. So it will be -6. So this will be separately taken. We will add it at the last. अभी क्या है कि we are taking this 10, this subarray, and whatever our k is, so this answer will be multiplied by how many times? 2 to the power k times. So my final answer will be 2 to the power k multiplied by answer. Answer means the maximum sum subarray. And then after that, we will add the remaining numbers there. Whatever remaining numbers would. And that will be my answer. Right. So if you will see my approach, my code basically, how I have solved it. So just see here. I have first of all use the Cardano's algorithm. So here I am using the Cardano's algorithm. I am not going to explain this. If you are confused about this Cardano's algorithm, you can check that out. This Cardano algorithm will find the maximum subarray sum for us, and which is answer. It will store it in the answer. Right. Now first of all, we will get the remaining. So we have the total sum of the array. So this is the total sum of the array. M. Currently M is the total sum of the array. From the total sum, we will remove the sum of this maximum subarray, so that we can get the sum of the remaining element. That I am storing in this M. Right. Now, my final formula is what? 2 to the power k multiplied by answer plus that remaining. So if you will see, what I have done here is, this is 2 to the power k multiplied by answer, and in the whole I am then adding this M, which was remaining. And because we have to give the answer is mod, in every arithmetic operation I am applying mod. Whether it is plus, multiply, divide, subtract, everywhere I'm adding plus. Even for finding 2 to the power k, I have used the power mod function. So that's the only thing. The formula was very clear, and this is how we have solved this particular problem with a great approach, right? I hope that you have got the complete understanding of this problem, and you have learned about modular arithmetic also. So in this problem, there were two learning. First learning was Karani's algorithm, right? This was actually a good problem. And second was the learning was how we can use modular arithmetics. Okay, these two learnings are there. Amazing, cool. Now let's move forward to the next problem, right? Which is the problem number C, which is tree cutting. Before moving forward, guys, let me tell you one thing, that I have prepared a sheet of 150 CP questions, which are really good questions from Codeforces and Codesef. And for each question, I have also have uh, my own recorded video editorial with it. Right. This whole sheet is gonna free. You will get this sheet for free. This sheet difficulty is from newbie to the specialist level. So if you are someone who are targeting to reach specialist, you can get this sheet of 150 CP questions, where for each question video editorial is also given. For getting this seat, I am not giving to everyone because I just want to give it to serious people. You can DM me on Instagram, only on Instagram, because my LinkedIn is already very uh, full of messages. So DM me on Instagram, just send me that, hi Abhinav, I want that seat, and I will share the link of that seat with you, which is completely free, 150 CP questions. So do DM me. The link is in the description. I will send you that CP seat. Okay, amazing, great. Let's move forward to the last problem, which is the tree cutting, right? For this video, basically the last problem. So this was actually a very interesting problem. Let me first tell you what the problem says, right? So the problem says that you are given a tree first of all. So let's take a very random tree. For example, let's take this tree. Okay, so this tree contain n as 6 and k as 1. What is k? I will tell you. Let's first see what tree is. Okay, so basically our n is 6. That means it has 6 vertices and 5 edges, because tree has n minus 1 edges, right? So these are the edges of the tree. First is from 1 to 2 to 3. Okay, this is a very boring tree. 1 to 2 3. Okay, let's take something else. Yeah, we can take this. Here the tree is that from 1 there is an edge to 2, then from 1 there is an edge to 3 also, then from 3 there is an edge to 4, and from 3 there is an edge to 5, and k is 1. So basically, guys, what this problem says that you have to actually make some cutting in the tree at k edges. So what you have to do, you have to remove exactly k edges from this tree. You can maybe remove this edge, or remove this edge, or remove this, or remove this, and so on, right? And by doing that, you have to find that what's the maximum number x that you can get, such that every component should contains at least x. Let me give you one example. Let's say if k is 1, means we have to make one cut. For example, if that cut I will make here, what will happen? This will become a separate component. This will become a separate component. This component has 4 nodes. This component has 1 node. So overall x is 1, because each component should have at least x node. So at least both have 1 node. We have to maximize this x, and that can be done. For example, if instead of here, if we will make the cut here, then this component has 2 nodes, this component has 3 nodes, and x will be 2, because minimum of 2 nodes both have, and we cannot maximize it more than 2, right? Let's take another tree maybe. So for example, if we even change the tree, let's say tree is something like this now, and let's say now k is uh, 3. We have to make 3 cuttings, right? So where can we make that 3 cuttings such that each component should have max like overall maximum? So for example, first cutting is here, second cutting is, let's say, here, and third cutting is, let's say, here. When you will do these cuttings, okay, so now if you will see, when you will make 3 cuttings, obviously 4 tree will be divided into 4 parts. The first part is this, which contains 2 nodes. This contains 2 nodes. This contains 3 nodes. and this contains 2 nodes. So means our x will be 2. And that is the maximum x that we can get. We cannot get more than that. Because that is what we will do. And for finding it, the only way is a brute force approach. Yeah, we will use the brute force approach only to solve this problem. Not very brute force, but yeah, we will use our approach of DFS and all to solve this problem. Basically, we will try to make cut everywhere in each edge, and then we will see till where we can go. The thing is, there should be max to max k cuts. There cannot be less than k cuts. Okay, and obviously we will not make more cuts. We will obviously try to make less cuts only, not more cuts. तो जितना ना करूँगे उतना कम वैल्यू हो जाएगी ना एक कंपोनेंट. So we will try to make exactly k cuts, right? And then we have to find okay in each component what's the minimum nodes that we have. We have to maximize that. So guys, how we will do this? What we will do, guys, that we will start from node number 1 and we will have a parent. So for node 1, parent will be 0. Now what we will do, from each node we will try to make some division. For example, first division we will try to make that okay, from 1 let's make this node division, and let's make this also. Let's check for both. तो जब ये दोनों division हो जाएगा, then for remaining node we will have again a DFS call, and then again a DFS call. And for each node we will see that how many nodes are connected to it. So if the number of connected nodes are, you know, less than something, greater than something, that can be our answer. But how? So we will also implement, guys, binary search in this particular problem. Means we will hit and try that for this particular value, is there a possibility? For example, अगर मैं यहाँ पे बोलूँ कि let's check for 3, क्या आप 3 वैल्यू ला सकते हो? 3 वैल्यू इज नॉट पॉसिबल, बिकॉज अगर आप आपको 3 कट्स मारने हैं, राइट? लेट्स से आपने पहला कंपोनेंट ये ले लिया 3 का, एक कट यहाँ मार दिया, दूसरा ये ले लिया, एक कट यहाँ मार दिया, अब तीसरा, अब आपको 2 और कंपोनेंट चाहिए, तो आप अगला कट नहीं मार सकते हो, राइट? तो 3 के लिए पॉसिबल नहीं. हाँ, अगर अगर ऐसा होता इफ कि के दो होता, if you have to make just two cuts, then x is equal to 3 was possible. How? एक यहाँ मार दो, एक यहाँ मार दो, सिंपल. तो यहाँ से 3 मिल गया, यहाँ से 3 मिल गया, यहाँ से 3 मिल गया, फाइनल आंसर 3. So it's not always possible, but we will make a hit and try using binary search, right? So let me explain now with the help of the code itself the whole logic of this particular problem, right? देखो, सबसे पहले तो मैं आपको बताता हूँ कि क्या किया है. I've taken an input in an adjacency list, right? Now, so see, at max x we can get is n, not more than that. So when k will be 0, we can get n at max x की वैल्यू एक कंपोनेंट में. मिनिमम we will get 1. एक से कम भी नहीं हो सकती, एक पार्ट में एक नोट तो होगी, राइट? Cool. So what we will do, between this L to R we will make a binary set. So first of all we will get a mid. Okay. Now for this mid we will try to hit a value. First we are making size of I equal to 0. So for every size, so we have taken an array of array size of some maximum length, and for every I from 1 to n we are making size equal to 0, because initially, so this size will store that for each node how many nodes are connected to it, means size of that particular component, right? Initially it's 0, we have taken. Now count is 0. Basically count will tell how many cuts we have made, and we have to make at most k cuts, right? Now we will call the DFS function from 1. Every time we will start from 1. Parent is 0. Parent 0 means obviously 1 के ऊपर कोई parent नहीं है, ठीक है? And mid means we want at least this much number of nodes in each component. तो हम इस mid के लिए hit and try कर रहे हैं. We are checking whether it is possible to get this mid or not. In the DFS what will happen? ये u आ गया. U means the current node, p means the parent of that node, and mid means that we want at least this much number of nodes in each component, right? First of all we made size of u is equal to 1, क्योंकि we have this component. अब ये component size एक ही है, सिर्फ वो component है, right? Now we are moving to adjacent nodes of that particular components. Basically उसके जितने भी childs हैं वहाँ जा रहे हैं. Also adjacent component में p will not consider because p is the parent. वहाँ से वो cut हो चुका है, वहाँ हम नहीं जाएंगे दोबारा parent के side. Otherwise it will be a infinite loop, right? अब for every component, for every node of this v, we will make a DFS कि भाई उसी component में कितना size आ रहा है. And whatever size of its component is, basically size means उसके जो childs है, component means sorry it's child, so v is the child of this u node. तो जो उसके childs हैं उनका जो size है हम u में ऐड कर रहे हैं, because उसके child उससे connected है. Node u is connected to its child, or basically not child, it's neighbor v. तो जो v का साइज होगा that will be added to the u size. u का साइज खुद का 1 है, but its neighboring size will be added to it, so that पूरा connecting component size आ जाए. ठीक है. Now after getting the whole size of this connected component, if the whole size is greater than equal to mid, and this is happening recursively. आप देखो बहुत सारे dfs कॉल होंगे, so for every component this will be checked. This is happening recursively, right? So if this is greater than equal to mid, because we want at least mid हो हर component में nodes. अगर size greater than equal to mid है and count less than k, because count should not be greater than k, it should be less than k, then only we'll move forward. And p is not equal to 0. p not equal to 0 means there should be some valid parent. p0 मतलब क्या था कि वो सबसे इनिशियल नोड थी, कोई उसका पेरेंट नहीं है, नहीं चेक करेंगे. अगर ऐसा है इंक्रीज के मीन्स okay, we have made one cut, and then again make size of u is equal to 0, means okay, अब इस वाले के लिए हो गया, अब नेक्स्ट के लिए फिर साइज 0 कर दो, राइट. अब देखो when we will call this dfs, we have got this count updated. Count will tell you how many cuts you have made for getting that mid. तो mid पाने के लिए आपने कितने cuts किए, that is what count will make. Now if count is greater than equal to k, see count should not be less than k. आप k से कम कट्स नहीं कर सकते हो कि भाई अब एक कट कर दिया तो आपको ऑब्वियसली दो बड़े बड़े कंपोनेंट मिल जाएंगे. आप ज्यादा कर सकते हो. फॉर एग्जांपल मैंने बोला कि भाई मेरे को मेरा x मेरे को 1 ही चाहिए, मैंने अपना मिड 1 ले लिया. अब मिड 1 के लिए आप कितने भी काउंट कर दो, हमेशा मिड आपका 1 आएगा. तो आप ज्यादा काउंट कर सकते हो, बिकॉज अगर आप ज्यादा काउंट कर रहे हो, ज्यादा कट कर रहे हो, इफ यू आर मेकिंग मोर देन k कट्स, राइट, then you can obviously ignore some cuts, because in ignoring some cuts even दो कंपोनेंट ज्वाइन ही होंगे तो वैल्यू बढ़ेगी, कम तो नहीं होने वाली. तो अगर कट्स ग्रेटर देन के भी तब भी चलेगा, कट्स ग्रेटर देन के भी चल सकते हैं, इक्वल ग्रेटर. और जो साइज ऑफ आई था, क्योंकि हम आई के लिए चेक कर रहे थे, वो मिड से बड़ा आएगा, बिकॉज दैट साइज, बिकॉज ईच कंपोनेंट शुड आल्सो हैव एटलीस्ट मिड नंबर ऑफ नोड्स. अगर ऐसा है, दैट मींस मिड कैन बी द आंसर. So we will store it in the answer and we will check for a greater mid. Else, if for this mid it was not possible, check for a smaller mid and finally print the answer. And because these adjacency vector and size, they were global component, we are again making them clear and making them 0 to be used in the next test case, because both test case में same use होगा, right? So guys, that is what we are doing in this particular problem. This was actually a good problem, a very good problem of tree. I will recommend you to please understand it very carefully, right? And I hope you have got the complete understanding of this problem. If you still have any doubt, please do ask that in the comment section, or you can also join our Telegram to ask your doubt. Okay, also guys, again I'm repeating the same thing. If you guys want the seat of 150 CP questions from newbie to specialist level, which will every question will contain video editorial by me, and this seat is free of cost. If you want that seat, please DM me on Instagram and I will share that seat with you guys, right? Thank you. I hope this video was helpful for you. Please do comment helpful if this is helpful. Please like the video and subscribe to the particular channel. Thank you.